This illustration deals with high impedance grounded neutral type systems in accordance with NEC 250.36 Informational Note. Now, the purpose of the change is a new informational note has been added to emphasize that high impedance grounding is an effective tool to reduce arc flash hazard levels in accordance with Annex 0 to NFPA 70E. Also places an informational note in 250.36 that highlights the safety benefits of a high impedance grounding system. You know, you can not automatically, but accidentally drop a metal bolt or something there and ground one phase out to the metal enclosure and so forth, and nothing occurs. It's dangerous. Creating an electrical arc that'd be danger to the user because it'd be the same thing as connecting to ground. See? Now, looking at high impedance ground, and you look at the calculation there for high impedance ground, and you can see that you can let 2 amps flow, 10 amps flow, you know, up to 20 amps usually is what they let flow. And then notice the service disconnecting means. First, system disconnecting means is listed at the very top of the where the window is, and you know the window is the most accurate means to detect when one leg is going to ground. And notice it's a 480 to 1,000 volt 3-wire system only. We don't have any neutral load. And then notice the high impedance grounded neutral conductor for 3-phase AC systems. Depending on your system, you might not want to run it that grounding conductor through the window. And then notice 250.36 again is 1,000 volts or less, and we would reference 250.187 for high impedance grounding and providing a window if it's over 1,000 volts. Now, I'd like to kind of review the information at the very bottom of the illustration boxed in, and it says the conductors of maintenance and supervision ensures that only qualified persons will service the installation. Continuity of power is required. Now notice there that it doesn't say that more safety is provided. You know, that's one thing I understand that OSHA did not want to say that it provided the safety of 70E and OSHA subpart S, because if it should go into a phase-to-phase fault, then it's just as dangerous, see, or could be. So they didn't want to do that. A few cycles back, or I shouldn't say a few cycles back, but a few additions back to the code, we added that and changed it. It said continuity of power is required. And then notice ground detectors are installed on the system line and neutral loads are not served. So that's the most important thing about a high impedance grounded system. Then the designer, the engineer, they'll design it with the impedance that they want for the amount of current they want to flow. And then notice the note 1, according to Annex 0 of NFPA 70E, high impedance grounding is an effective tool to reduce the arc flash as outlined in 250.36 informational note. And then for the definitions of a high impedance ground, see 250.20D and Article 100, and we kind of get a definition of a high impedance ground. But it does provide a margin of safety for anything that goes to ground on L1 and L2, but just one, not two, then it pretty well, it provides a margin of safety. But if it goes phase to phase, no, it will not. So that's why the OSHA folks, as my understanding, wanted to, well, it's over in 1910 304 G1, Roman numeral 5B, as you see in the OSHA outline table at the top, and then we would kind of look that up. So that is the impact of this new informational note, is to to put you on to high impedance grounding. And then the only thing you look at, do I bring the neutral, or should, you know, because all it does is detect any leg that goes to ground. Do you bring it through the window or not? So that's the thing that we're talking about here.